Hello class. So I just wanted to go over this question here because some of you had issues going through it. Here it says a chemist wishes to determine the rate of reaction of zinc with hydrochloric acid. The equation for for the reaction is zinc plus 2HCl. Aqueous gives you hydrogen gas and H2 gas and zinc chloride aqueous solution. A piece of zinc is dropped in a 1 liter of 0.100 molar HCl, and the following data were obtained. And here we have the data listed below. The first thing it asks you to calculate the rate of reaction in grams of zinc consumed per second. So that's the first thing here, and here we're assuming that we're talking about the average rate. So we're going to look at, this is your mass final, and this is your initial mass. How do I know which one is initial, which one is final? Is because of the times. Okay, the first one is at time 0, the last one is at time 20 seconds, which is the last one in the table. The first thing here that it asks is pretty straightforward, not different than what you learned in starting grade 6, I believe, or grade 7. So the rate is the change in the y over the change in the x. So technically this is on the y-axis and this is on your x-axis. Again, something you probably learned in grade 10 is, and probably before, hopefully, is that time, if it is there, it is often on the x-axis. So that's an easy hint. But the only one that we're going to be doing in this course is the rate of reaction. So just look at the amount per time, and it also says so in the question itself per second. So it tells you grams per second. So it says what you need to do. So we're looking for the change in mass over the change in time. Change the delta. Delta always means final minus initial. Okay, so that's always the case. 2 minus 1, whatever, second minus the first. So in this case, we're gonna have the mass final minus the mass initial, or final mass minus the initial mass, divided by the corresponding time. So the final time minus the initial time. And these number that corresponds to these values, or these amounts, we have 0.006 grams minus 0.016 grams, and that should be divided by the corresponding times 20 seconds minus 0 seconds. You don't have to put the units on each single one of those here in this step. That's just a bit too time consuming and could be messy. So you're gonna end up with 0.01 grams, and we're not doing significant figures in this video. Divide by 20 seconds. Okay, so use your calculator, divide 0.01, divide by 20, 20, you get 0.0005 grams per second. So that's your first one. Second thing here, it asks you to calculate the rate of reaction in moles of zinc consumed per second. So you already have the grams per second for magnesium. If they want the moles, so really the only thing that you're switching is you're switching this grams, you're turning it into seconds. That's the only thing that you're doing. You're turning it into moles. So you're going from grams to moles. So that's really what is asked of you in the second question here. So you're going from grams to moles, and every time you do that, you have to use a periodic table. So use periodic table. for the molar mass, in here it's just magnesium, so you just look at magnesium in the periodic table and you're gonna get that 1 mole of magnesium equals 24.3 grams of magnesium. Okay, so you're going to use that conversion factor and the rate. So the new rate that you're looking for, in B, it's going to be the molar rate, moles per second, moles of magnesium per second. That's going to be starting with the number that we have already from the first question, which is 0.0005 grams of magnesium per second. You multiply that by your new number that you got from the periodic table, or not the new number, but the number from the periodic table, and before you put the numbers in, put the units. This is unit analysis. So you want moles to replace the grams and the grams to cancel out with the moles, right? So to do that, you're going to have moles per gram. So it's 1 mole per 24.3 grams, and that's again from the periodic table. So the next thing is a calculator. So now that you end up with moles over seconds, you stop. You don't need to do any more. You don't need to look for any conversion factors or any other thing that you need to multiply by. So at this point, you use a calculator, and you're going to go with the first thing you have, 0.005 times 1 divided by 24.3, or you can just divide by 24.3 right away, and you end up with, so 0.0005 divided by 24.3. Okay, so you end up with 0.0002058, or somebody might say it's 2.06 times 10 to the negative 5 moles of magnesium per second. The last thing or part C, write out the complete ionic equation of this reaction. So this is from solutions. So we're looking at this reaction up on top. Okay, so the ones that we need to break into ions are the zinc chloride and the hydrochloric acid, HCl. You don't touch the zinc. The zinc and the hydrogen gas do not get touched because you have solids and a gas, so those come down as they are. So that's what we're gonna put right away. And hydrogen to gas. And let's break down those ions. So you have 2 hydrogen ions, and they're aqueous, plus 2 chloride ions. On the other side, we have 1 zinc ion and 2 chloride ions. So that's it for the complete ionic equation. What will happen to the hydrogen ion concentration? So if you look at the hydrogen ion concentration here, be careful. They're talking about the hydrogen ion concentration. So that's your hydrogen ion right there. This is not hydrogen. So H2 is not hydrogen ion. So be very careful. It's H plus. This is H so this is this is a neutral molecule or atom, the atomic molecule, and here you have ions, not the same things at all. Okay, so this is the name of the chemical species, H plus. This has no H plus anywhere, it's H2. Okay, so they're not the same. So what happens here? So as the reaction moves forward, the reactants always get consumed and the products get produced or increase in concentration. So really what happens here is this, so the concentration, I would say it would decrease. And for the chloride, it's also tricky. Somebody would say, okay, it's on the left side. Don't pull the trigger yet. It's on the left side, and also it's on the right side, the same amount. So you have 2 moles on the left side, 2 moles on the right side. So if you have 2 moles on the left and 2 moles on the right, what's the difference? Nothing. There's no difference, so no change. Just be careful. Try not to always rely on memory or what you have seen before. Try to think about the situation in front of you, because there are many different situations, and the question could be asking about something specific, and you need to be able to answer it. That's it.